Hi, this is Mladen Ivanovic from complementarytraining.net, and in this video I want to chat a little bit about training load and different ways to analyze it and visualize it. And I'm going to continue basically my discussion on training stress balance approach, and I'm going to suggest one adjustment that could be useful, especially when visualizing and just quickly analyzing workloads. What we have here, for a second, just disregard these two pictures. In rows we have days, training days, and we have, I think, 3 or 4 periods. So we have a base, building, hard training period, and off. And on each day we have 4 different sessions, or 3 different sessions and a day off. And here we have a training load in the D column. So for every type of session, Excel is randomizing between minimum and maximum value, which we can pick up from this table. So easy is from 10 to 40, medium is 40 to 80, and hard is 80 to 150. You can play with this just to see how it works and how it affects the metrics. So in base period, we have basically only medium and easy. In a building period, we start using basic medium, hard, easy, or hard, medium, easy. Hard period has more hard and medium sessions and less easy sessions. We have an off period where we don't have any trainings, and then we basically repeat base, building, and hard training, with a slight modification that hard training is becoming really hard over here, and that could be visualized on a graph over here. So let's cover the first graph. The vertical bars are the daily training load. Again, this is arbitrary units, and as you can see, this phase over here, the one I mentioned before, has a lot of hard sessions. And what I did, the simplest and quickest analysis I did is 2 rolling averages. We have acute training load, which is 7 days rolling average. That's a red line over here. And we have chronic training load, which is a 6 weeks or 42 days rolling average. And that represent, as I covered before, represent the chronic training load, and that can be tracked. That could be a proxy to something that might be a long-term adaptation and work capacity. What's interesting in the ratio between those two. So if you check the first graph over here, we can. I mean, it takes maybe 42 days to, just get everything correct. So first 42 days, in this case, because we're using 6 weeks rolling average for a chronic load, the formula is just accumulating data. So we can disregard this because they are pretty much similar. But after 42 days, approximately here, or a bit further down, 41, 42, we can see that there's a difference between acute and chronic, which means that training load is being increased more than athlete is used to it. And we can probably say that this athlete can expect some fatigue-based syndromes. Again, it's the poison is the dose makes the poison. So again, depends on what's too much, what's too little. In this case, I've used the ratio. So you can see that sometimes we have like 20 to 30% more acute, bigger acute training load than a chronic training load. I guess some literature suggests 10% should be maximum, maybe 20%, but again, depends on what's the actual training load, and might differ from athlete to athlete. And again, it differs if he already did that volume before. So if he used to that volume, you can ramp up the volume quite quickly. So you don't need to follow this 10 or 20% rule, which is common in endurance sports. So again, we see what's happening in when we have an off period. We have a quick drop. We have a quick drop in acute, which might mean that the athlete can be tapering, but over time he's losing his chronic training load, and that means he's basically detraining, even if he's tapering here. And that's what I like to call catching a wave, especially in season for a sport such as soccer, rugby, volleyball, or other team sports that have a long season. So if you create a lot of perturbation inside the season, you kind of get off the wave, and then you need to catch another one. So basically you just need to take the wave all the way to the shore. Actually, might be a bad analogy, but you don't you ride a wave and you don't get too close to the shore because you're gonna get smashed. You kind of step down and take the another one, but the difference shouldn't be that big. Basically what I'm trying to say is that we are more interested in a performance maintenance than peaking, because after the peak, when we peak, our acute training load needs to drop compared to the chronic one, and the athlete is going to be peaking. Basically his performance is going to be increased, but after that period we basically need again to catch up, and that can cause cause detraining because the chronic load is dropping, and since we are increasing the acute training load, and that's going to be bigger than a chronic one, that can cause fatigue related syndromes. So again, the difference between acute and chronic in season, as far as I'm concerned, they should be minimal. We still need some variation, we still need some waves, but we cannot afford big drops, big waves across the chronic training load. So the chronic training load should be basically a straight line with minimal ups and downs, and acute training load should follow it with small waves instead of just dropping and going up and dropping. At least that's my opinion. Again, it comes back to what's the training load. So it could be GPS stuff. Again, some of the GPS devices provide around 200 metrics, so we can probably create 200 graphs like this, and we need to decide what's the best estimate of the training load. So we covered acute training load ratio, which basically tells us when the acute is too high compared to the chronic. In my opinion, we need to put that into a context. All the ratio measurements, all the difference measurements, we need to take the values that produces them into account as well. In this case, we need to take a cumulative sum. So this is a rolling sum, again 42 days, but it gives us a cumulative load. So instead of taking an average, we are taking a sum, the rolling sum, and that's red line in a bottom picture. So we see the load is ramping up. So what it is saying that in the last 42 days, the athlete has this amount of load, and we can see that that's being progressed, and that's quite expected because we've been increasing the amount of hard and medium sessions, and decreasing amount of easy sessions, and again dropping in the off season, call it off season, or the period we don't have any sessions. And we need to take this the red line into account when we are comparing these. So again, we might expect fatigue related syndromes here because acute training is bigger than a chronic one, but we also need to check the red line, the cumulative one, because it's not a big load. Basically we can have this area here shifted up, and that could be more problematic than being a little bit down, as you know, when we are coming from the off period. Again, that's why we need to put things into context and check the cumulative also as well. So basically acute, chronic, and cumulative chronic one that can be checked. And the black line here is just my play a little bit with the numbers. What I did is that I adjusted the training load based on the monotony. So monotony is basically the rolling standard deviation. So again, this is all chronic. So this is over 42 days. So we have standard deviation over 42 days. It gives us idea of how varied the training load is. And monotony is just the average chronic training load divided by standard deviation. We get some index of variation. So the bigger this number, the higher the monotony. It means that the training is more monotonous. So we don't have too much hard, easy. So in this case, in this base period, we have numbers over around 1. And if we go to a hard, we get much bigger numbers. Let's compare this one. Base is, because it takes time, as I said, after 42 days for the system to kind of catch up. We have 0.6 to 0.7 or 0.80. And in a hard period, we have 1.3, which means that the training is not so varied here. And that's one of the, in all training loads, that's one of the adjustments factor that should be applied to a training load. So we have this monotony, but I also, so the adjusted training load, what I did here in a black line, is that I multiply the chronic sum, the chronic training load that's summed, multiplied by the ratio of acute to chronic, and multiplied by monotony. So the training load is bigger if we have more monotonous training, and the training load is bigger if we have high ratio between acute and chronic, which means that in plain English, I'm adjusting the training load based on the monotony of training. So more monotonous training is harder to recover, and I'm also adjusting at the, let's call it a velocity or speed of increase. So if acute training load is higher compared to a chronic one, that means we are increasing the training load too quickly, and I'm taking that into account. As you can see, the adjusted training load is more like exponential, and it's pretty much dropping to 0 compared to the red one. That means we didn't have any sessions here, and probably athlete is losing work capacity and losing training adaptation. And again, is slightly different than a chronic one here, because it shows that athlete is coming off from the training and basically, let's say, refreshed. So the training load here is not that high compared to the red one, so it takes into account the recovery happening here as well. Again, most of these metrics needs to be validated in terms of, are they actually correlating it with some real events, let's say injuries, underperformance, overtraining, if that actually exists, burnout. And I hope to someone to do it, or myself to do it in the near future. So if we have events here, injury or lack of, or maybe wellness questionnaire as well, we can probably correlate a couple of options and see which one correlates the best to actual real stuff happening. It might be actually a performance test or something like that, and see what type of training load is negatively or positively affecting the performance, or more performance-based metrics, real-life metrics. One thing we can do after this one, after this adjustment, maybe we can plug this into a Bannister model, and it might give us better prediction. I'm just brainstorming. Hopefully I might try it in the next couple of weeks or something. Again, that's all. Hope that this makes some sense, and you can try implementing this in your own training load monitoring. Thanks for listening.